Alright, now I'd like to do section 9.3, number 20. Now, this problem again is using half angle formulas, but now it's a little different because we're going to have an x in here that we don't know, whereas before we were just computing it at those values. So they want us to find sine of x over 2, cosine of x over 2, and tangent of x over 2 if we knew that tangent of x is minus 4/3 and x is in quadrant 4. Okay, so there's only one little trouble with this, in that we're now wanting to find the sine of this thing and the cosine of this thing and so on, and we're going to need to know the SIGN sign of those expressions to decide whether we're going to put a plus or a minus in the front here. Now, it wasn't such a problem on the earlier the earlier problems because, well, we had a specific angle. But now we just we don't know the specific angle in this case. It doesn't matter. We can still do it. So because this angle is in quadrant 4, we know it's in here somewhere. So we know that this angle x is smaller than 2 pi, if we're thinking of a positive rotation here. And it must be bigger than the south pole angle. Well, the south pole angle is 3 pi over 2. Now, inequalities act like equalities. If I divide by 2 here, because that's what I'm going to need to know about if I'm going to talk about sine of x over 2, for example, I have to do it in all 3 parts. So I'm going to divide the first one by 2, and I'll get 3 pi over 4, because dividing by 2 is the same thing as multiplying by 1/2. The middle term is going to be x over 2, and the right-hand side is going to be pi, because 2 pi divided by 2 is just pi. Well, what quadrant are we talking about here? So x lives here, but where does x over 2 live? X over 2, well, that's an angle bigger than 3 pi over 4. Now, here's 1 pi over 4. 2 pi over 4 is the North Pole. 3 pi over 4 is right here at this position, the middle of quadrant 2, and it's smaller than pi. So x over 2 lives in this little wedge here, in that little area. So it's firmly in quadrant 2. So this tells us that x over 2 is in quadrant 2. And why does that matter? Well, because when we compute the sine of x over 2, since it's in x over 2 is in quadrant 2, we'll know that the sine is a positive. We'll know that the cosine is a negative. So that was important. But other than that, the rest of the problem is basically the same as before. I'm going to want to compute sine of x over 2. How will I do that? Well, I'll use the half angle formula on the side over here. And to do that, I'll need to compute the cosine of the angle. So I need to take this information about the tangent and be able to compute the cosine. Well, that just means I need to draw a triangle. Okay, most of trig works this way. So I take my everyman's triangle here. I put x in here, and then I have to fill out the sides to match 4 and 3. So the adjacent over the opposite, the opposite over the adjacent. So here's 4, here's 3, and here's unknown. Well, by Pythagorean theorem, that tells me that 3 squared plus 4 squared is question mark squared, or in other words, 9 plus 16 is question mark squared, or in other words, 25 is question mark squared. So question mark must be 5. It's a 3, 4, 5, not square root of 5. It's equal to 5. Square root of 25 is 5. It's a 3, 4, 5 triangle. So what's that tell me? that tells me that the cosine of x, being the adjacent over the hypotenuse, is 3 over 5. But is it positive or negative? Well, I'm having x here. And x is in quadrant 4. In quadrant 4, cosine is positive. So this is positive, adjacent 3, hypotenuse 5. So positive 3 over 5. Now, I'm going to need that when I use my half angle formulas. Notice on the side, all these formulas have the cosine in it. Both of these, sine and the cosine half angle, have a cosine of that numerator in it. So I can now compute sine of x over 2. Now, as we discussed earlier, x over 2 is in quadrant 2. Therefore, the sine of x over 2 is a positive, because in quadrant 2, your y values are positive if they're above the x-axis. So we're going to take the positive square root of, and looking at the formula, 1 minus cosine x all over 2. Well, we know cosine x. It's positive root, 3/5. So I get square root of 1 minus 3 over 5 all over 5. And we can clean that up a little bit if we wanted to. It would be square root of 2/5 over 5, and that 2/5 is really 2 over 5 is really 2 over 25. So you could write it as root 2 over 5 if you like. But I would accept this as an answer as far as I'm concerned. Similarly, cosine of x over 2. X over 2 is in quadrant 2. So we know that the cosine here is negative, because cosines are first coordinates, they're x values. And to the left of the vertical axis, x values are negative. So we actually get a minus square root. And then according to the half angle formula, I take 1 plus cosine x in there. So I get 1 plus cosine x all over 2. So I'll end up with a negative square root of 1 plus 3 over 5 all over 2. And that will simplify. What will it simplify to? 1 plus 3 over 5 is 8 over 5. Oh, I made a mistake earlier, didn't I? I did. This 2 should not have become a 5 earlier. My apologies. So this thing is not the answer. It's actually square root of 1 over root 5 is actually what it is. My apologies. So this thing, the cosine is actually square root of 8 over 5 over 2, and that will end up being 4 over 5, and root 4 is 2, so you get negative 2 over root 5. Again, I would accept that as the final answer for that problem. I don't care if you simplify in trigonometry. It's not algebra class. So finally, tangent of x over 2, well, that's just sine of x over 2 over cosine of x over 2. And so what does that mean? Well, we go to our sine calculation and we get 1 over root 5. That's what I computed here in the red after I corrected it. And on the bottom I get negative 2 over root 5. Now I can flip and multiply at that point, and if I do, then I'll get a value of negative 1/2. And that is number 20. I'd like to do another one of these, number 23. It's the same instructions, except now the information that we're given is that the secant of x is negative 4. So number 23, if secant of x is negative 4 and x is in quadrant 2. Now in this case, If x is in quadrant 2, it means x is in here. And so that means that x is smaller than angle pi because it's not quite making it to pi. I mean, that's what quadrant 2 is all about. But it's also bigger than pi over 2. So again, I'm interested in computing sine of x over 2, cosine of x over 2, and tangent of x over 2. I just didn't want to write all those instructions. So I'll have to, again, divide by 2 my inequality, and I'll get pi over 4 divided by x over 2, or is less than x over 2, is less than pi over 2. Now, what quadrant are we talking about if that's where our x's live? Well, x over 2 is bigger than pi over 4. Well, that's, right there, that angle, and it's smaller than pi over 2. So we're talking about this wedge in here. X over 2 is in quadrant 1 in this case. So when we calculate sine of x over 2 and so on, all these will be positives. So notice something here. We actually have an easier solution here than we had before, because secant is the same as 1 over cosine. So since secant is 1 over cosine, these things are equal, right? So I can actually solve this for cosine x. If I take the reciprocal of both sides, I'll get cosine x is negative 1/4. And that's really all I need to use these half-angle formulas. Look, inside these square roots, I just have cosines. I don't need to draw a triangle or anything like that because I lucked out. So we can jump right in. Sine of x over 2. Now x over 2 is in quadrant 1. Therefore, I get the positive square root of 1 minus cosine x all over 2. Well, 1 minus cosine x, well, cosine x is negative 1/4. So this is square root of 1 minus negative 1/4. Now that double negative can be tricky, but you have to just put things in as they are. It's really 1 plus 1/4, and that's 5/4. So you really get square root of 5/4 over 2. In other words, square root of 5/8. And that's sine of x over 2. Now, cosine of x over 2 is similar. Okay, cosine of x over 2. X over 2 is in quadrant 1, so it's a positive root. And I'll get square root of 1 plus cosine x all over 2. But cosine x is negative 1/4, so square root of 1 minus 1/4 is what I get. You could write it as 1 plus negative 1/4, it's the same thing. And so you get square root of 3/4 over 2. In other words, you get square root of 3/8. So finally, tangent of x over 2, that's sine of x over 2 divided by cosine of x over 2. And that's, square root divided by square root is just one big fat square root. Let me write it, I guess, as both. Square root of 5 over 8 divided by square root of 3 over 8. We can write that as one big fat square root, flip and multiply, and you could see that that's really the same as square root of 5 over 3. So that's how you would do those half-angle problems.